In this class, I'm going to give you a small demo on how to use an HDL language to implement a small function like hardware description language. So how is it different from a software language is that here we are this particular language is targeted towards implementation of digital logic circuits. Okay, so the language is whatever we use here is to describe the structure and behavior of electronic circuits, right? So it is not an general software here. This is more targeted towards hardware require. The output will be right and hardware circuit. So that is where the difference lies. Okay, so it is more complex in nature. So there are basically two very widely used hardware languages. Hardware description languages. One is known as Verilog, the other is known as Vhdl, right? So this circuit, once we see one example, it will be very clear. This language we use to clearly define the digital circuits. It is like it is equivalent to drawing a circuit diagram, right? Instead of making an schematic, drawing a circuit level and implementing, we can write an program out here, and the compiler will make the circuit for us. So it is like a language which is essentially making an schematic. Okay, so that is the difference with regards to an software language. Now also an advantage of this is you can do logic simulation, and that means once you have designed a circuit, you can also test whether the output, right? So you can within the program you can write some test conditions and see whether it is the output is available or not as desired. Okay, the next slide explains that. So first we write an Verilog code here. So if I run that code, right, this gate will be this circuit will be implemented, right? So this circuit will be implemented based on the code which I write, right, whatever is the functionality. So like for in this particular case, it is an full adder, so A, B, C, so sum and carry. So I write a program for a full adder, so this circuit will be implemented of its own. And then after that I can do logic simulation. That means the software also provides provision to give inputs, to change the inputs and see what are the outputs. So now if you see here in the timeline, various A, B, C are changed from 0 to 1 and 1 to 0, and I am seeing whether I am getting the correct output or not. So that is what it is. It is known as logic simulation is also possible. And now there are two, like I said, there are essential most widely used two HDLs. One is known as Vhdl. Okay, this was developed by a US Department of Defense, and the other one is known as Verilog HDL, and this was developed by Cadence, but as of now it is transferred to an Open Verilog International. It is now this is being used by Xilinx and everywhere it is used, very widely used. So we are also going to use this particular code. So you will have, so in Verilog code you will find there is a specific set of syntax is available. So you can download, there are several books are available, or even otherwise if you just Google syntax for Verilog, you will get a set of all the syntax which are there for Verilog. You will get as an PDF, right? There are several keywords there, so you don't have to remember everything, all these things. Okay, so there are 100 keywords which are predefined. They're all in lower case. Like for example, a module is a start of a module, end module, input, output, and a wire, and or not. So as we keep moving forward, we will understand the meaning of each of these keywords also. So this is to comment out. If you want to insert comments, and you can use double slash. Blank spaces are ignored, and it is everything is case sensitive. Okay, you need to remember this when you are writing codes, right? So you can Xilinx is free of cost. You can use this particular link to download their the Xilinx onto your PCs. Okay, so if you are working in a company, most of you might have Xilinx already there, or if it is not there, you can download from this link. I'll share this link also with you. So you need to give your email of bits email, because it is a student version which is freely available here, right? So if you use your bits email ID, then this will work fine, right? So don't give your personal email ID, give your bits email ID, so this will work from this link. So I'll share this link also with you after the class through the Taxila. Okay, now I'll give you a small demo of this particular circuit. I'll show you how to start the Xilinx software and implement this circuit. So this circuit is A and B, right? And then you have a NOT gate here, so you have an OR gate here. So you have an Y as an is C bar, whereas X is A and B or C bar. So these two outputs, 3 inputs and 2 outputs. So this needs to be implemented. So this is known as wire, right? Because this gate is to be given inputs, right? So one input here is Y itself, because this is Y. And what about the other input? So so internally this is known as we need to define the output of this gate. So this is known as a wire. Okay, so this wire is not available as an output, right? Because that is not required. But internally I require this. I need to declare this W1 so as to use an input to this gate. So this is known as a wire out here, right? So if you see here, so this is how I write the code out here. So once you do a few sample codes, so you will become very familiar with Verilog. Okay, so this is how the code looks like: module and a sample circuit. So this is the name of the module. Okay, so this is the simple circuit I have. This is what I am going to demonstrate to you. So this is module name, I have given it as simple circuit, and within brackets I need to define the inputs. So input is A, input is B, input is C. That means I have got 3 inputs and 2 outputs, output X and output Y, right? So these are the 2 outputs which are available. So I'll share this PDF also with you. Okay, don't worry about it. So and then I need to define one wire. Okay, so this wire is not available as input or output. That is available just inside the circuit itself. So I am declaring this wire out here, right? So now the first I am writing it is AND. AND means an AND gate. So this is the syntax which is available in Verilog. AND means an AND gate. Now there can be many ANDs and in a circuit, right, which you are designing. So I need to name each gate. There will be many gates like gate 1, gate 2, gate 3, gate 4. So I have to give the name of the gate. So I am giving this name as G1, right? Then the syntax goes like this. This is the output and these are the inputs, right? So the output is W1 and the inputs are AB. So obviously once I write this command, so this much will be implemented, right? One gate and then AB. Okay, this will be implemented out here. Similarly, Y. Not means it's an inverter. G2, which is this, I am writing one more name. If I don't give this name, there will be a syntax error. And similarly, I can't give G1 here. I have to give different names for each gate. Okay, I am writing G2. This is Y, and then C. This is the output. This is the input. Okay, and now again I have one more OR gate, G3, and that is OR between wire 1 and Y, right? And then end module. So it starts with a module and ends with an end module. This is the name of the modules. You describe the inputs and outputs and then the wires, right? And then if you see here, this is to be used to stop the to go into the next line. So this needs to be there, right? So everywhere here. Right. So this is how I write a sample program to implement this circuit. Okay, so I'll show the demo for this. What you need to do is you need to implement this circuit. Okay, implement majority circuit. Okay, what does a majority circuit do? Like if this is a 3-bit majority circuit, if there more than 2 ones, the output will be 1. So for the first 3 combinations, you will find the output is 0. Then for this I have 2 ones here, so that why the output is 1 here. Again here also there is only 1 here. Again for the last 3 combinations there are 2 ones, so this will be f. So if I try to write an expression for this, it is an AB plus BC plus CA plus ABC. So this is actually redundant, so I have to implement f is equal to AB plus BC plus CA. Is the problem definition clear to all of you? Okay, so you got to implement this majority circuit. Is it okay with all of you? So this is what. So what you are going to do is you are going to do download Xilinx and implement this circuit and save the circuit and keep it with you, right? So before midsem only. So I am going to, in the next class I am going to give you one more small problem, and then in the subsequent class I am going to give one more problem. So there will be 3 problems altogether. All the 3 problems in one go you will show how you have implemented in before your midsem. I'll send to you a notice where I will explain you how to submit these files, and when is that you going to demonstrate these circuits to me. So accordingly they will be assessed. So this is going to be how we are going to do the assignments. So let me close this. Now once you install the Xilinx, so this is the kind of a window. It will take you at a virtual machine. So in case you are getting problem, getting stuck with installation or anything, you are free to mail me, or you could also call me up or WhatsApp me. So this is the number which I have given on the chat box. So you can save this number. So in case you are getting stuck for any reason, right, installation of Xilinx, or you are not getting the desired results, so you can always WhatsApp me, or let me yeah. Okay, but this course is these are all free software, so you'll have to take the we can't do it in mobile. Okay, so we'll have to find some ways and means to do these experiments in your, even if you are all together, even if you have one laptop, so you should be able to share it and do it. Okay, so let me demonstrate this how to use this. So I create a folder first. Okay, say lab1. I created a full working directory out here, right? So lab1. Once I have created that, I will click on project navigator. So this will open Xilinx. Then let me close this. I'll go to file, new project. So let me call it as a lab1, and the location. Yeah, this is going to be working directory is going to be on the desktop and the lab1 itself. Okay, okay. Now HDL. This has to be selected to HDL. Next. Okay, now if you see here, by default it is Verilog, and the simulator is ISIM Vhdl Verilog. So you have to ensure that these are the two which is there. By default it will be there as it is. In case it is not there, then you need to select this accordingly, right? So I do finish, right? So I have this lab1 now, and I have created an project. I do a right click, I write a new source, right? Now I am going to write sample. I am going to create a sample. You have to create majority carrier, but I am doing just a sample, and I am going to make a Verilog model. I have to select this. Okay, Verilog model sample, right? So next. Right now here I get a window out here, input. Now this is input. I have A, I have B, and then I have C 3 inputs, right? I have two outputs, right? I have Y and I have X. I have got, let me change this to output, and I put out and then finish. So if I do that, see the sample code has already come here. Module, sample, input A, B, output, and these are the things which has already come here. So now I have to define an wire also. So I write a wire W1, right? So I'm defining a wire also out here, and then not or like I explained it in the PPT, and G1, that is the gate. Okay, the output is going to be wire 1, right, and the input, and I am going to do an AND of A and B there, right, and then I am going to have an NOT operation, right, and I am writing G2. The output is capital Y, and then and I'm going to have C out here, right, and then I am going to have an OR operation, G3, right, and I am doing an operation between, and the final output is going to be X for that, and it is an operation between OR operation between Y and wire, right. So I do that, and then it's an end module, right. So once having done this, okay, I have this, right. So I can I have to select simulation first, right. So I'm not implementation means when I have to implement it. Right now I'm going to simulate it. Sample, I have selected this. I do here. First I do right. I tick simulation, and then I come back to this sample here, right. I have selected this. Now I am doing a behavioral check, right. So it will say, so it is doing, and if there is any syntax error, it will throw the error out here, so you can accordingly correct that. Okay, once you have, that means the syntax is correct. For example, if I write here, and if I do an, so this is a syntax error, right. So it will throw error. It will I have to do a rerun all. So it is giving, say, syntax failed, and it is giving at this line, okay, modder. So it is saying, okay, this is there is an error here, where it will specify here in the log. It is at line 30 W1. Okay, it is saying W1. What is it? It's not understanding what it is. So I have so that is so you seeing through the log you can do. Now the behavioral, now I do a simulate behavioral check, right, after that. So I'll get an these are the various inputs A, B, C, and these are the various outputs, right. So I can go and set the values. Okay, now I right click on it. I do force constant, like I put a 1. Okay, now if I press 1, okay, this will not change. That means high impedance. It will not change till I run it. Okay, force constant, right. If I put 1, okay, A and B I have put 1, C force constant, C I am putting it in a 0. Okay, so now I will run it, right. So now you will see the output. Now it is A is 1. Now once I run, this gets updated. It is 1. It is 1, it is 0 here. So it is like Y is not of C, right. So this is 1 here. X is AND of these two, so this is 1, and right, no, W1 is AND of AB, so I get 1 here, and here I am getting. So I see these results can be seen in the waveform also. So this is working fine for this particular input combination, right? So I can change the combination also. For example, now I go to force constant method. Right now I am going to set an A as 0, and C, let me set it as force constant. I set it as 1. Okay. Now I am going to run it again here. Right. So now I find A is 0, so AB, which is W1, has become 0 out here, right? And also C is 1, so C bar is also 0, hence the final no, X is also 0. So for this condition also, this is meeting, right? So I can click on this. Right, this was the initial junk. Now two runs I have given here, so both I can see here. So with these 3 inputs, I can have 8 different combinations. So I can give all the 8 different combinations and keep running it and verify whether the circuit is functioning perfectly fine or not. Okay, so that is one way of doing it. Okay, the next way is, let me close this window. Yes, now this code is available here, right? Sample code. I right click, I write an new source, right? Now I am writing an Verilog text fixture, right? So I am writing it as sample test, right? So I am making a test fixture. Next, and now I have to, now since there is one schematic available here, there could be many such schematics available, right, modules available. So for this I am making a test fixture for this particular Verilog module. So sample is here, so I press nice, I press finish, right? So now it has created an test, okay, test bench. This is known as an test bench. Now if you see here, it says A is equal to 0, B is equal to 0, C is equal to 0, and wait for hash 100 means wait for 100 nanoseconds, right? So what I can do is I'll copy this, Control C. Okay, I am going to paste it here. Now I am going to put C is equal to 1, right? Now after waiting for 100 nanoseconds, again the new test vector will be given 0, 0, 1, and again it will wait for 100 nanosecond. So I am going to copy this and I am going to put it here. Okay, A has not got copied, so A here. So now I am going to give another test vector 100 nanosecond, right? So if you see here, then after 100 nanosecond, 100 nanosecond, 300 nanosecond, it will do. I can write a dollar finish, okay, to stop here. Otherwise it will run for 1 microsecond, which is the default. So I write dollar finish, right? So if I write a dollar finish, then it will after this activity it will finish. Otherwise it will run for 1 micro, which is the default setting, right? So now I have this, I am clicking on this. Now I do a behavioral check for this. So it means it is working fine. There is no issues with the syntax. Then I press the simulate behavioral check. So here if you see, it is all the test bench has, I have given 3 different conditions. For these 3 different conditions, it has as per whatever I have given, right? I have made an I have written a program here, right? Test bench. So different conditions I have given, 3 different conditions. You can write 8 different conditions. I have just given a sample for 3 different conditions out here. Sorry. So it has done an simulation for all the three different conditions, and then it has given the results of all the three different conditions here, right? So first the last window will be shown here. So if you click on this on full view, the three different conditions here, and it has stopped after 100 nanosecond, 100 nanosecond, 100 nanosecond. Otherwise it will run for the last condition, it will stop at 1000 nanosecond, right? So these are the three different conditions, and these are the results. So you don't so this is how you create a test vector and do the testing. Okay, is it understood by all of you? Okay, so we'll stop it here for today.